All right. So this section deals with, we're getting into what's called a distributive property, but we have to first talk about how to combine like terms, what a like term is, how we multiply numbers by terms that contain variables. So there's some different rules that go with that. So we're going to cover that today. But just as a review, terms, we talked about terms in our previous notes. Where are they? Term. A term is any number, variable, or product of a number and one or more variables. And then we talked about how terms have value. So they're either positive or negative. So we've talked about this a little bit where we talk about the number of terms that you might see in a particular problem set. So this example right here would have had 3, a negative 4, a positive 3x, and a negative 8z. So now we're going to practice identifying terms and what we can do with them if they are like terms. All right, so we are able to combine terms as long as they are like, and we do that by adding or subtracting the coefficient of those terms. So first of all, what is a coefficient? The coefficient is the number being multiplied, that is multiplied by a variable. A variable. All right, so in these examples, so the coefficient of 3x, the number that is being multiplied by the variable is 3. In this term, remember terms can have more than one variable. So negative 4xy, the coefficient of this is negative 4. And then this is one that always throws people off. If I just see a negative z or just z, then our coefficient is 1. So in this case, it's negative 1. If I just see z, my coefficient is 1. Sometimes putting the 1 in there helps you, but just know that there is a coefficient there, even though it's just assumed that it's 1. All right, so when we have like terms in a problem set, you can add or subtract, or basically you're combining the terms. And we've talked about adding and subtracting integers, so it's the same rule that applies. So like terms have the same variable factors to the same exponent. And the exponent piece comes into play because if I look at, for example, this and this one, well, this is a 3x and 6x. This is a 3x to the third and a negative 6x to the third. So that little 3 there makes it so that they're not like terms with this. The only things that are like terms with a 3x and a 6x is something that's being multiplied by x only. If this was a third there, then those would both be considered like terms as well. But they're not, so we cannot combine them if they are not alike. So we can add or subtract like terms. How do we do that? We combine them by adding or subtracting the, you guessed it, coefficient. My pen's a little janky, but it's up here. F-I-C-I-E-N-T. Okay, so we can do it by adding those two. So if I look at this, and I need to practice on identifying terms. In this case, I have a positive 3x, and I also have what is a, change colors there, a positive 6x. Now, when we are working on examples of combining terms, I want you to make sure that you have the value of the term grouped with that particular term. So in this case, that positive goes with that 6x. So when I look at these two, I have a positive 3, positive 6. When I combine them, they equal 9. In this example, I have a negative 3xy, and I have a positive, I'm going to group that plus with this 12y. So I have a negative 3 and a 12. The signs are different, so we can take the difference between them and keep the sign of the bigger number. So that would be 9. The difference between negative 3 and 12 will be positive 9, and then we include those variables, those x and y's. All right. So part of it is, again, is boxing like terms. So let's try one more practice. Let's do a 4x minus 3 plus 5x plus 10. All right, so the first thing, if I'm going to combine terms, now this particular problem has 4 terms in it. You can see it, 1, 2, 3, 4. And if I ask you to tell me what terms they are, and to be specific, you would say it's a positive 4x. And maybe I'm looking for another term that shares that. And I can see one right here. But I'm going to include that positive with it because the sign to the left goes with that term. So I have a positive 4x and a positive 5y. So if I combine a positive 4 and a positive 5, that becomes a 9x. So those would combine to become that. Now, another term that I see, and everything is a term that's separated by a plus or a minus. I have a negative 3. Then I also have a positive 10. Note that I am including that positive within it. So then a negative 3 and a 10, I can either do 10 minus 3 or negative 3 plus 10. You can type that into your calculator. You would know that that is a positive 7. Now, I'm not just going to write down 7 because when I'm rewriting this to simplify, I would actually indicate the value in between the terms so I know that they're separate. So this example would simplify to 9x plus 7. All right, so we're going to try a couple. I left this in the notes. The quantity of represents numbers inside grouping symbols. We're not going to cover that today, but we will tomorrow, and so it goes with the distributive properties. So the quantity, T, oh no, I guess the is T-H-E. Hello. Didn't pay for the version that I can edit, so I just have to keep going. The quantity of. And I'll talk more about that when we get into actual distributive practice. So let's go ahead and take a look at these 4 example problems. We are going to simplify each of these by combining like terms. So if I look at these like terms, I have a 7y and a positive 6, and they're both y's, so 6 and 7 would be 13y. I have a 3t and a negative 1t. Think of it as a negative 1. 3 minus 1, 2t. I have a negative 3w and a negative 9w to the third, and negative 3w to the third, and because they are both raised to the third power with the same exponent, they are considered the same. So that would be negative 12w to the third. And again, all you have to do is focus on the coefficient, negative 9 minus 3. Here I have an 8d and a positive 1d. Think of it as 1. That becomes 9d. All right, so I left another example. I typed out another example that I would like to go over as a class or for you guys to have in your notes. So in this case, let's take out this revealer. I want to go through and I want to box each one of these. All right, and what I'm going to do is I'm going to start with the first one. So if I look at this, I have a negative 8x squared. And I can see I have 1, 2, 3, 4, 5, 6 terms. I'm going to look for another one that has an x squared in it. And as I look and I go down this line, I see this one, positive 2x squared. So those are like terms, which means I can combine them. Negative 8 plus 2, just the coefficients. That would be negative 6x squared. So we include that. All right, now I'm going to take a look at this next term I see. This is a positive 2x. A like term with a 2x, or any x has to contain an x. And if I look, I see this 4x. And again, I'm going to include that plus in there. So then I have a positive 2 and a positive 4. 2 plus 4, that equals 6. So that would be a plus 6. All right, and then I have a negative 3. Constants, and we talked about what a constant is. It's just a term without a variable, are obviously considered like terms because we can add or subtract them together. So I have a negative 3 and a positive 10. Take the difference is 7. The bigger number is positive, so that would be a plus 7. So this simplified would be negative 6x squared plus 6x plus 7. So that's how we combine like terms. You're looking for ones that numbers that have the same variable to the same exponent, and it could be multiple variables. You could have an x and a y. Right? That means they're still like terms, and then you add or subtract the coefficients, or you combine the coefficients is what I like to think of. All right, the next part multiplying terms, and we're just going to talk about multiplying terms by just a whole number. All right. When we are adding terms or subtracting terms, they have to be alike. However, multiplying, we can multiply any number by its coefficient. So for example, 4 times 4x, we can do that. We couldn't do 4 plus 4x. We can't call that anything. We can't call that 8x. That does not equal 8x. We just have to leave it like this, okay? Because they're not like terms, so we can't do anything. However, we can multiply. So if I have a 4 times a 4x, I can just say, hey, it's 4 times 4 is 16 and leave the x there. 3 times 5y, 15y. All right, this works for division as well. You can divide and simplify that way. So if I look at these problems, 3 times 2x, well, 3 times 2, I'm just multiplying by that coefficient is 6, and then you're including that x. 7 times 3, 21x. 5 times 2xy, that would be 10xy. 3 times negative 5y, well, 3 times negative 5 is negative 15, then y. And again, you can divide too. So if I have a, let's say, 8x divided by 2, well, this 8 divided by 2, that equals 4, and then include the x, 4x. So you can divide as well, and we will do this when we are simplifying problems later. You'll have to divide out a term to make some other problems work, but that's the quick rule on that. So we can multiply. We can't add them unless they're alike. They have the same variables, but we can multiply or divide by a whole number, a term that contains variables.